Hi, welcome back. In part two this week, now that we know about Perlin Noise, which is a way that we can generate a random number, not random number sequence that is kind of smoothly changing, smoothly varying, let's apply this to a simple little drawing machine. We're going to use Perlin Noise to animate the motion of first a single point, then we'll add a second one, and then we'll connect these points with a line and then see what that looks like. So let's just dive right into it. As usual, I made a new sketch here. I'm going to start by changing my canvas size and my background color. I'm also going to save it just in case something happens. There we go. And just like in the previous sketch, we're going to bring in our dat.GUI library over here. So just to refresh your memory on how to do this, I go to the cdn.js for dat.GUI. Link will be in the description, but of course you can just Google it. I'm going to copy the script tag and I'm going to go into my index file and dump the script tag over here after p5 and p5.sound. Okay, so still inside the head tag here and save. Okay, so now we have access to dat.GUI. We'll use it when the need arises. But first, let's talk about how we would draw a point, a moving point using noise. So we're going to start with just simply the x value for a point. And what we're going to do is we're going to take the noise function. Now we know that if we feed noise an increasing number, okay, we're going to use frame count because we're lazy. We're going to get a randomly changing value that is somewhat continuous. Okay? And that number is always going to be between 0 and 1. So we're going to multiply that by the width in order to scale the full width of our screen. Okay? Let's set a white stroke before I forget, and also draw a point. So let's draw a point. And for now, we're going to just put that point in the center here. And let's see what that looks like. Okay, so it's a little bit hard to see. Stroke weight. Let's increase the stroke weight to 5 for now, just so we can see what's going on. So we can see a point here moving a little bit erratically. And that's because, again, frame count is increasing by 1 in each frame. And between 0 and 1 and 1 and 2 in this Perlin landscape, there's actually a huge jump. So if we want to see some smoothness, we have to divide that jump. We have to make that jump smaller. And that can simply be, let's just make frame count smaller. Just divide it by here a factor of 100. And now all of a sudden we get this kind of erratic motion. But now we can see it's moving smoothly from one frame to the next. Okay? So it's unpredictable, but also it's got this interesting behavior to it. So this number here, this kind of speed factor, could be interesting to be able to play with it. So let's create a GUI for ourselves. I'm going to create a variable here, just call it GUI. In setup, we'll say GUI equals new GUI, dat.GUI. And then we're going to create an object called settings. Again, that object doesn't have to be called settings. That's just what I like to call it. And inside of it, we can start to put the variables that are basically going to act as like the global parameters for our program, the global controls. And let's create one called speed. And we can start speed at the same number we're using here. Instead of using the hard-coded value here, we will say settings.speed. Okay? And then we will add this as a slider to the GUI. We'll say GUI.add. First parameter is the object containing all of our settings. The second parameter is the name of the setting we're adding. And then because we want this to be a slider, we're going to provide a range. And that GUI is actually a very clever library. It automatically figures out what kind of variable this is. And it has different types of GUI elements that are not just sliders, things like buttons and checkboxes and things like that. But we will stick to sliders this week, and we'll explore more advanced uses of it in coming tutorials. So here we specify a range. So let's go from like, I don't know, something like this. And we can always go back and tweak that range to something that suits us later on. So now I can make this point go rather quick or rather slow. Okay, if I make this a really small number. Okay, so this is now the slowest end of my range. Awesome. So what we're doing, to recap here, is we're using Perlin Noise to set the x coordinate of a point, right? And we are animating the point by simply moving across this noise landscape. We're feeding it frame count as the parameter, and we're just dividing to slow down the speed at which we're moving across the landscape. And then because Perlin Noise always gives a number between 0 and 1, we scale it up here. We could use map, but I'm being lazy. I'm just multiplying by the width so that it fills the entire window. All right, so now that we have this point moving along the x-axis, let's also get it to move in the same way along the y-axis. Okay? Now, we might be tempted to simply replicate this command. Okay, say, all right, let's also get a y coordinate using the noise function, right, which gives us random numbers. And then we're going to put in y here as our point. However, if we do this, we're going to be quickly reminded of the one important property of Perlin Noise, which is for a given input, right, you will always get the same output once the program has started. That sequence will be random every time you restart your sketch or your program, but once it starts, unless you change the seed, same input gives you same output. So if I use the same input here for both calls to noise, I'm getting the same value out of it, which this is why my point is moving along, always along a diagonal. Okay, this has the same x value and the same y same y value. So how do we make them different? Well, it's very easy. We can just say, because we know this landscape is very unpredictable, right? We can simply say the x value is going to come from one part of the landscape, and then the y value, we're just going to sample some points further down the line, okay, so that we make sure they're not the same as the x value. So how do we shift further down the line? We can just add some constant offset here. So I'm just making this up here, 100, right? That should be pretty far down the landscape. And then we do the same thing. We add frame count and then the speed. Okay? So that's going to ensure that both of these are going to be Perlin Noise generated value, right, from the same sequence, but we're taking points at different places on the sequence. So they're never going to be the same, or at least they're going to vary differently. Okay? So now we have our little point moving, and it's getting its y value from one place and its x value from another place. And these are always the same distance apart, but it doesn't really matter because essentially like this sequence is always changing. So in practice, we're basically getting two different random number generators. Okay? So that's a neat trick. We don't even have to talk about two-dimensional noise this week. We can just keep adding offsets to get different noise values that are not the same using the same input here. And if we're curious, we could also see, we could use this as a really basic drawing machine. Imagine this is the head of a pen here on a sheet of paper. This is what the path of this point looks like using Perlin Noise. It looks very complex to program, but it's in fact quite simple. It's kind of this erratic motion that still has this organic quality to it because it never jumps too far from one point to the next. And yeah, so now we've created a scribble maker. Very nice. Now we're going to use this idea to make maybe a little bit more of an interesting drawing machine. And by doing so, we're also going to think about this concept of creating some framework, right? Where here we're going to have a framework where we're going to create 2 points that are going to be moving on the screen. Our 2 points are just coordinates. And then we can think about mapping all kinds of things on top of that framework. Last week, we created a grid, and then we had a flip coin in each cell of the grid, and you came up with your own interpretations of that framework. This is going to be a similar idea here. So, of course, a single point, right, is a little bit trickier to come up with different interpretations, but, I could imagine instead of a point, maybe I draw a line here, right, from 0, 0 to xy. And now all of a sudden, this is the same program, the same moving point, but I've just created a different interpretation of that framework, okay, of that system. So let's make the system a little bit more interesting by having 2 points. Okay? Stop this here. So let's make another point. So now that we're going to have 2 points, just to keep things straight, we're going to call this x1, y1. Okay, so that's going to be our first point, and then we're going to simply copy and paste this and we're going to create x2, y2. This is going to be our first point and our second point. And we want all these to get different values. So I'm simply going to give each of these a different offset. So they're all picking their random values from different places on the noise landscape. And we can see what that looks like here. We're going to draw point x2 and y2. Very neat. Okay, so now we've expanded this framework. We have one moving point, right? And then another, and they're kind of like dancing around each other. We could put the background back into draw. So if we don't necessarily want them to leave a line here, this is what they're doing. Okay, so they kind of look like these little, maybe little flies or little fireflies moving around. And again, there's no intelligence in this behavior, right? It's simply just randomness, but controlled randomness. So it's a little bit more interesting than just pure randomness, because of the way that it moves is more organic, is more compelling. And we can project all kinds of things onto something simple like this, right? To me, they look like they're flying, and then sometimes they come close to each other, right? Sometimes they move apart. Again, this is not something that we programmed in. It's just a side effect of the noise, and we can take advantage of it if we're interested in that. So one thing we could try to do as a simple interpretation of that framework is let's connect the dots. Instead of drawing two dots here, we are going to draw a line. So let's draw a line from y1 to x2, y2. x1, y1 to x2, y2. Cool. So now it looks like maybe a Jedi training with his lightsaber. Now we've created a new interpretation of that framework. We could imagine again maybe going back to putting the background into draw. Okay. So now we get something like this, and something we could vary. We could think about varying the. Let's add some settings to this. Maybe we'll change the alpha value of this line so that instead of being just white, we could say, what if I put a semi-transparent line, right? Just to kind of play around with textures a little bit, make this a little bit more interesting. I get something like this. We can go back to a thin stroke, perhaps, right? So let's make the alpha value. We could also make the stroke thickness a parameter. Let's make the alpha value a parameter we can control, just to get some practice. So the steps to add a parameter to our GUI, we simply add another variable in our settings object. Let's call this one alpha. And maybe the default is going to be 50%, like 128. Remember, alpha values go from 0 to 255. Then we are going to use that here to set the alpha. So settings.alpha, which is a variable we now just created. And in the GUI, we are going to add a slider for the alpha value. And this slider will have a range from 0 to 255. Okay. Sweet. So now we can adjust the transparency of our line. We can make it very transparent. Right? So now we can barely see it. Now we can adjust this as a control. If we wanted to, we could add the line thickness, like anything that you think you might want to play with and control. You can simply just add to this interface. And now we have an engine, a framework that we can tinker with, we can play with to create interesting outcomes. So this is a neat, cool little drawing machine here. One limitation that it has is that it's always going to be drawing on top of what's already there, okay, which is neat. You can get some really cool results like this. But it's kind of limited over time because the lines we drew at the beginning, right, it's always eventually going to start creating just a very full image. Okay? So sometimes it can be beneficial to be able to control the length, or I guess the number of things we're drawing on the screen, and not always rely on this accumulation effect from never clearing out the background. So just for fun this week, we're also going to add to this program the concept of a recorder. Okay? So the way this is going to work is we're going to, rather than just rely on background being inside setup and then draw never erasing the background, we are going to record the motion of these points, store that into a list, and then define a number of frames, a maximum number of frames we want to record. So let's say we want to record the last 50 frames or 100 frames. And then in each iteration of draw, we're going to replay the whole sequence. And first, we're going to clear the background, and then replay the sequence. And that will allow us to basically set the length of this trail here and have a little bit more control over the outcome of our program. So how would we record the points? Well, the points in a frame here are these four values, x1, y1, x2, y2. So we could imagine something where to create a simple recorder, we need kind of a data structure that's going to hold all four of these points. So just for simplicity here, we're going to create an object called frame, and I don't want to have to change this code over here just yet. So or these variables. So we could simply say here, inside this frame object, we're going to make x1 equal to y1, or actually, let's do it that way. We're going to bring these into here. Can I use noise in there? I'm not sure. Let's do it that way. So we're going to say x1 equals to my x1 variable. Okay, we're going to keep the same names. y1 equals y1. x2 equals x2 equals x2, and y2 equals y2. So the idea with this object here is I'm going to create a variable called frame, and inside of it, I'm going to pack all four of these variables I just made over here. Okay, so not the most like optimal, efficient way of doing this, but maybe the most clear or less obfuscated. And then when it comes time to draw the line, we're not going to change it for now. Okay? So the idea with this is now we have a variable that contains all four coordinates of the points, right? All four numbers that make up the 2 points. And all we need is some kind of list, some kind of array that we're going to keep adding at the end of it. So in order for us to record every frame. So let's create an array here. Let's call it the recorder. So it's just simply going to be an empty array. Okay? And every time we create a new frame, we're going to say recorder push frame. So push is a function of the array object in JavaScript, and it simply says take this variable and add it at the end of the array. Okay, so we're going to add to the end, and if we, of course, keep just doing that forever, this array is going to keep growing forever, but we'll fix that in a second. And then what we could do is first we're going to move background back into draw so that we can see that we're actually going to be recording and then playing back what we've recorded. We're going to clear the background, and then we're going to write a little bit of code here, which instead of drawing the point directly, is going to go through every frame that we put into the recorder array, and it's going to draw a line using frame.x1, frame.y1, frame.x2, and frame.y2. So right now it looks the same, okay, because we are just forever adding frames to this recorder array. But the big difference is we are clearing the background at the beginning of draw here. So we are in fact recording the motion of the points that we had, and we are redrawing the entire image in each frame. Okay, so that's a very important distinction. If you don't believe me, we could just add a circle. Just a little circle following the mouse cursor, and see it's not accumulating on the background, right? It's not creating this sort of trail effect. That's because we're clearing the background and then redrawing the whole sequence in each frame. So why would we want to do that? Well, we can put a limit on how many frames we save. So for instance, we could say if recorder.length, right, is greater than a certain number, let's say 50, what we're going to do is we're going to remove the oldest frame, in other words, the frame at index 0. And there's actually a command in the array class for us to do this called shift. So shift removes the object at index 0, okay? And that basically shifts the whole array one position to the left. Let's try that. Cool, right? So now we're only recording 50 frames and then playing this back here when it's time to draw. So we could imagine this number, that might be something useful for us to control in our GUI. So let's add a setting. Let's add, let's call this number of frames. and that's going to go as short as 1 to, I don't know, 500. Okay, just making this up. And we're going to add a variable to the settings here called frames. And let's use 50 as our default that we have right now. Nice. So now we could change the number of frames, and if we increase this number of frames here, oh, it's not going to do anything because I haven't changed this number here, right? So we got to make sure we use the variable we just made. Settings.frames. My bad. Try again. So if I increase the number of frames now, this trail is going to start to get longer, right? It's now recording for longer, right? Because it's allowed to add more frames to the end of this array. And we can increase the length of the trail. And of course, we can still change the speed. If we really like make the speed go up, then these points jump all over the place. And we can change the alpha, right? And notice how it's affecting the entire pattern. That's because we're redrawing the whole trail every time. Now, there's going to be one problem here, and that is if I go from a lot of frames and then try to make it less, like try to kind of shrink this trail here, it's not going to work. And the reason that happens is because we are only ever removing one frame, the first frame per iteration of draw, because we have an if statement here. So if we went from like 400 frames down to 49, we'll never catch up. We have to be able to remove more frames in order to go from a large number to a small number. If we just do one every time and then we keep adding one to the end, we'll never catch up. So one thing that we could do here is we could replace this if statement with a while loop. Okay, so a while loop is conceptually very similar to an if. It says if something is true, right, keep doing something as long as the condition is true. So we could say as long as recorder.length is bigger than our desired number of frames, right? As long as we have too many, keep calling recorder.shift so that we just keep throwing out old frames until we reach the correct size. Okay, so we're going to replace this with a while. Let's see what that does. So you got to be a little careful with while loops so that you don't have an infinite loop condition. But in this case, we're not going to run into that issue. So now I can increase the trail length, but I can also decrease it. And you see now when I decrease it, right, it basically just automatically throws away all the extra frames that it doesn't need anymore. So we can go from just having one kind of dancing line that we started with. We could increase the number of lines that our program is drawing and yeah, play around with that setting. Really neat. Okay. So that's this example where we took 2 points and animated them with Perlin Noise. So in other words, we created some kind of generative framework where we said we're going to animate these points here, these numbers, and then we're going to interpret them as a line. In the next example, we're going to build on this. Just those of you who are interested in going a little further, we're going to say what other kind of interpretation we could do of this framework. I'm going to say instead of a line, we're going to draw a square, okay, but still only using the 2 points. We're going to kind of use our line as our guide here, and we're going to draw a square that's going to follow the rotation of that line. Okay. So yeah, that's going to be the next example. I'll see you in that one.